I want to figure out how blood gets from my heart, which I'm going to draw here, all the way to my toe. And I'm going to draw my foot over here and show you which toe I'm talking about. Let's say this toe right here. Now, to start the journey, it's going to have to go out of the left ventricle and into the largest artery of the body. This is going to be the aorta. And the aorta is very, very wide across, and that's why I say it's a large artery. And from the aorta, I'm actually not drawing all the branches of the aorta, but from the aorta, it's going to go down into my belly, and it's going to branch towards my left leg and my right leg. So let's say we follow just the left leg. So this artery over here on the top, it's going to get a little bit smaller, and maybe I would call this a medium-sized artery by this point. This is actually now getting down towards my ankle. Let's say we've gone quite a distance down to my ankle, and then there are of course little branches, and let's just follow the branch that goes towards my foot, which is this top one. Let's say this one goes towards my foot, and this is going to be now an even smaller artery. Let's call it small artery. Small artery. From there, we're actually going to get into what we call arterioles. So it's going to get even tinier, right? It's going to branch. Now these are very, very tiny branches coming off of my small artery, and let's follow this one right here, and this one is my arteriole. Arteriole. So these are all the different branches I have to go through. And finally, I'm going to get into tiny little branches. I'm going to have to draw them very, very skinny just to convince you that we're getting smaller and smaller. But let me draw 3 of them. Now let's draw 4 just for fun. 4 of them. And this is actually going to now get towards my little toe cells. So let me draw some toe cells in here to convince you that I actually have gotten there. Let's say 1, 2 over here, and maybe 1 over here. These are my toe cells. Toe cells. And after the toe cells have kind of taken out whatever they need, maybe they need glucose, or maybe they need some oxygen, whatever they've taken out, they're also going to put in their waste. So they have, of course, some carbon dioxide waste that we need to drag back. This is now going to dump into what we call a venule. A venule. And this venule is going to basically then feed into many, many other venules. Maybe there's a venule down here coming in, and maybe a venule up here coming in, maybe from the second toe. And it's going to basically all kind of gather together and get into a giant, giant set of veins. Maybe veins are dumping in here now, maybe another vein dumping in here, and these veins are all going to dump into an enormous vein that we call the inferior vena cava. I'll write that right here, inferior vena cava. And this is the large vein that brings back all the blood from the bottom half of the body. There's also another one over here called the superior vena cava, and this is bringing back blood from the arms and head. So these 2 veins, the superior vena cava and the inferior vena cava, are dragging the blood back to the heart. And generally speaking, these are all considered, of course, veins. Let's back up now and start with the large and medium arteries. These guys together are sometimes referred to as elastic arteries. Elastic arteries. And the reason they're called elastic arteries, one of the good reasons why they're called that, is that they have a protein in the walls of the blood vessel called elastin. They have a lot of this elastin protein. And if you think about the word elastin or elastic, obviously very similar words, you might think of something like a rubber band or a balloon. And that's probably the easiest way to think about it. If you have a blood vessel, one of these large arteries, for example, and let's say blood is under a lot of pressure, right? Because the heart is squeezing out a lot of high pressure blood. This artery is literally going to balloon out, and if you actually looked at it from the outside, it would look like a little sausage, something like this, where it's puffed out. So what's happened there between the first and second picture is that the pressure energy, so the heart is squeezing out a lot of pressurized blood, and of course there's energy in that blood, right? That pressure energy has been converted over into elastic energy. It's actually converting energy. We don't really always think about it that way, but that's exactly what's happening. And when you convert from pressure energy to elastic energy, what you're really then doing is you're balancing out those high pressures. So you're balancing out high pressures. high pressures. And this is actually very important because the blood that's coming into our arteries is under, let's not forget, high pressure. So the arterial system we know is a high pressure system. So this makes perfect sense that the first few arteries, those large arteries and even those medium-sized arteries, are going to be able to deal with the pressure really well. Now let me draw a little line here just to keep it straight. The small artery and the arteriole, these are actually sometimes called the muscular arteries. Muscular arteries. And the reason, again, if you just want to look at the wall of the artery, you'll get the answer. The wall of the artery is actually very muscular. In fact, specifically, it's smooth muscle. So not the kind of muscle you have in your heart or in your bicep, but this is smooth muscle that's in the wall of the artery, and there's lots of it. So again, if you have a little blood vessel like this, if you imagine tons and tons of smooth muscle on the outside, so let's draw it like this, little bands of smooth muscle. If those bands decide that they want to contract down, if they want to squeeze down, you're going to get something that looks like a little straw because those muscles are now tight. They're tightly wound, right? So you're going to create like a little straw. And this process is called vasoconstriction. Vaso just means blood vessel, and constriction is kind of tightening down. So vasoconstriction, tightening down of the blood vessel. And what that does is it increases resistance, right? Just like if you're trying to blow through a tiny, tiny little straw, there's a lot of resistance. Well, it's the same idea here, and actually a lot of that resistance and change in the constriction or vasoconstriction is happening at the arteriole level. So that's why they're very special, and I want you to remember them. From there, blood is going to go through the capillaries. I didn't actually label them the first time, but let me just write that here. Sometimes they call them capillary beds. I'll write that out. And then it's going to go and get collected in the venules and eventually into the veins. And the important thing about the veins, I'm going to stop right here and just talk about very briefly, is that they have these little valves. And these valves make sure that the blood continues to flow in one direction. So one important thing here is the valves. And remember, the other important thing is that they are able to deal with large volumes. So unlike the arterial side, where it's all about large pressure, down here with the vein side, we have to think about large volumes. Remember, about 2/3 of your blood at any point in time is sitting in some vein or venule somewhere.